Welcome to another video and episode on the Arduino Yun with embedded Linux connected to network and USB storage. Also connected obviously to Breadbrothers Electronics and fischertechnik mechatronics. In particular motorless propeller, as you can see, as well as a continuing chain, which goes without saying, but with a lamp, and a phototransistor. And there is a bit of a problem here because 5 volts coming straight from here is not enough to really light the lamp. It just gives a glow, which is not enough for the phototransistor to make it switch and give a signal to the Yun, to the Arduino. But that comes later. Also later comes some stuff with RC circuit, another RC circuit, and NTCs, if I get to it. I already made some rewiring, but first focus is not now to change settings and give the usual data acquisition or create it and store it on here, but to continue where I left last time, which is creating subplots within the mathematical program Octave, which is a high-level programming language as well. And last time I realized that I made a mistake in creating the graphs. So let me see if I was right in that. After that I can create new stuff and hopefully incorporate some new things. And maybe change the algorithm so that these are truly independent, because right now they are not. So let's go to screencast with Octave and see whatever goes next. And here you can see obviously the oscilloscope, which indicates that the pot meters are down next to 0. There's no signal coming from the phototransistor, and there's nothing coming yet from the board to this LED. Anyway, it's now filling with zeros, so no need to look at datalog.txt. What I do need is going here. This was the place to get. This is where I get not very useful graphs. And when I press F5, I get a nice graph, but it's absolutely what I need. Not in the least. And I can't even get it away. Mostly because of this, I think. Oh, right. And then I get this one. Yeah, okay, I should. Going, no, wrong link. Yeah. These lists are partly because I haven't. Now I have to look for it. I haven't put a semicolon behind these lines. This line, this line, this line, and this line. That means that they are giving their output in the command window. Why is that coming in nice and handy? Because then I can see which entries are 0 and which are not. And there are a lot of zeros. But what I need to do is, yes, find which entry is 1000, but this is time. Voltmeter, pulse modulator output, and the C value. This is the one that should be taken. Not AX, but BX. So BX against CX1. BX against DX. And BX against EX. And then, is that all? Well, actually, no, it's not. Because what do I have? Going back here, I have, and I'm talking about the 1000 range, the 1000 value. I do have 6 values. Let's see, this is 1, or should be 1000. Where is my 1000 entry? Here. So I have 1. Oh, wait. Where's 2? Here. This is 2. Sensor value switch. I have 1 which I ignore now. 2. So this will be entry 1. X axis. 2, 3, 4, 5. So, and the C value, alright. Which, no, 5 is then and the C value now. So, that will be digital, digital read, digital in, which is wait a second, digital in, that can only be from the phototransistor, is my guess. But it's there. So let me add that. And then F is file AX1 6 FX1 is F, and that's it. This will be all 0, no doubt. But at least now I have 4, this is BX, 4 of these. So, let's run it. Ah, that's very different. Now that is very different. Starting from 0, all of them. Although all of them, not quite. And should I make it clear, if possible? But this is starting from 0 and going all the way up. This is... Oh wait, yeah, I should do something else as well. This is spot meter. So next one is this. Let me see, X label. No, this is a Y label, because this is it, and this, and this, and then Y label will be NTC value. And photo transistor. That will be better in meaning. So now let's see whatever is going to happen, and I probably have to, yeah, I have to recreate it. Oh, of course. Once more, quit, and go. Right, and this doesn't make sense. This does not make sense. Why does it not make any sense? Because the value is not going up of the photo transistor. So somehow I make a small mistake here. Not quite sure where my mistake is, but can I do this for the other values? Yes, of course I can. So I can do this in the same figure, so that I have 4 times 4 figures, and then I have to add 1000, 1001 and 1002 and 3 to them, and then I can see whatever the difference is. So that sounds like a nice idea, but this really doesn't make sense. Let's just view, and there's another catch. Okay, I have to open a new window, and because I have to take the version that is on this side on the laptop, and I have to look at FX, and FX says column 6, 1, 2, 3, 4, 5, 6. Yeah. Now the question is this really the photo transistor? I doubt it. I think this could be it. On the other hand, I have here 1002 and 1001. I'm looking now at 1000. Let me go back to the start. This is 0. This is 0 and I'm using now 1000. Yes. AX 1. So that's a bit illogical. Which one is which? Where does it start to count? Looking here, again it says 1000, the first element, but Octave is counting from 1, not from 2. So 1, 2, 3, 4, 5, 6. But oh wait, this is 7. 0 through 7. This is the one I have to take. So I make a small mistake here, which also means that I made a small mistake here. This is 6. 2, 3, 4, 5, 6, 7. Second column, fourth column. This should then be not column 3 but column 4, column 5, column 6 and column 7, and this should be column 3 then. Am I correct? 7 columns for the C algorithm. 0, 1, 2, 3, 4, 5, 6. For Octave, 1, 2, 3, 4, 5, 6, 7. So this needs to be 7. Now let's see whatever the difference really is. And here, quit. This figure doesn't make any sense at all. Go and run. That makes much more sense. At least for the phototransistor. Voltmeter I'm not sure of. Pulse modulation likely. And C value also not quite sure, but values are values, no denying. So that's one thing. That means that I have to find a way to make the phototransistor work, because duplicating all this for these values goes without saying. Don't need to show you well how I do it, but putting things into a figure, sure. And yeah, quit and there. This one. So there we have it. Back to the come on. Back to this one, or more appropriately this. How to really fix this? Not really sure yet. In order to find a solution for this mechanism, I have added a battery pack and come to a surprise, because Well, a battery pack is DC, direct current. Look at this wave. That is not direct current. More like alternating current, AC. Apart from that, right now the voltage looks like some 5 volts. Previously it looked more like 9 volts, which it should be unless this battery is running down fast, which is of course possible, but this is currently the source for the lamp that is burning brightly right now. But if you look at this line, I expect the transistor to have a very good signal. It's not showing anything at all. So let me put this probe here. Nothing at all. It's a voltage divider, so if there's nothing here, there's nothing further. I can of course increase the lower the voltage, but this is now 0.2 of a volt. 1 volt, 2 volt, 5 volt, nothing. So I am very much wondering why, if the transistor does do anything at all, and why this battery shows like AC instead of DC. And right now I do not have an answer. I could use the power controller, of course, which I've used before. That is guaranteed 9 volts, but it's also pulse width modulation. I might do that, because I am not quite sure which voltage is on this battery pack right now. So although battery packs should be working nicely, I don't trust this alternating image. So let's for the moment grab the power controller and see whatever happens. And now I have put the power controller in place, and looking at the graph, it's not making things any easier and clearer. One thing is clear. The lamp burns at full force. The signal is not really pulse modulation, although pulse channel 3, which is this one, giving a clear signal, but that is more like AC than pulse modulated. And this is a clearer signal than this, but even when I switch it off, it has some weird wave. So I'm not sure if this is due to the probe being or rather not being grounded. Just a thought coming up. So let's careful with the wires and hook it up to a ground, which doesn't make any difference. No, does not make any difference whatsoever. So I have to find another solution for this. How this will end up, not a clue. But one thing is clear, I have to change this installation, because this is clearly not working correctly. Not with this battery pack, which gives a very strange idea, and not with the power controller. Too bad. But things like that happen from time to time. And that is the end of this episode. So it's rather chaotic now, but it doesn't make any sense either. With big improvement in the graphs, still need to work on the 1001, 2 and 3 value ranges. Still need to work on the electronics with respect to which controls what, and then this whole thing needs to be reworked so that I can control this one with that. And most likely also the flashlight that I've used previously, this one, but this one is constructed in such a way that the lamp shines from up down, down to up, so I would have to put it like this, and it's better when, for a flashlight that I can put it the other way around. But that's a matter of construction. And with that I say, yeah, well, with this graph-like, no response, which is strange, odd signal, and voltages on the pot meters. Thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion. Also, you can follow me on Instagram and Twitter. Please support the blog by making a small donation via either PayPal or Wired. And you can also choose to become a patron and have your name mentioned as a supporter, depending on the pledge you make, on my website anyway. Your name will be mentioned on my website, but by depending on the pledge, also with my videos on one way or more. This is going to be continued, obviously. Once again, thank you for watching, and